The first few 100 million years after the Big Bang remained the last unexplored era in the history of the universe, and the James Webb Space Telescope, equipped with highly sensitive infrared instruments, is the perfect machine for the job. Within the first few weeks of its early data release, dozens of galaxy candidates from that epoch have been reported. But the most interesting of all is the recently discovered Schroeder's galaxy, which seems to be in two places simultaneously. So what is so special about the nature of this distant galaxy? Why is it the strangest galaxy found so far in Webb's data? Finally, and most importantly, how does it pose a threat to our existing models of cosmology? Redshift. Since light travels at a finite speed, everything we see in the universe is how it looked in the past. So, if a galaxy is 12 billion light-years away, we are actually looking at the light it emitted 12 billion years ago. But because of the universe's expansion, the wavelength of that light increases by the time it reaches us, that is, it becomes redshifted. Astronomers denote redshift by a dimensionless quantity, z. Z equals 0 represents present time, and as its value increases, so does the look-back time and the distance to the celestial object. Photometric redshift. One way to determine the redshift of a galaxy is by analyzing it in different standard color filters. This gives us the galaxy's photometric redshift, which, unfortunately, isn't too reliable. The accurate redshift of a galaxy can only be found by studying its spectral lines. So, the spectroscopic redshift is the gold standard for determining extragalactic distances. To date, astronomers have confirmed the existence of only one galaxy in the Z greater than 10 era of the universe. It's a galaxy named GN Z11, discovered by Hubble in 2015. But galaxies having redshifts greater than 12 cannot be observed by Hubble. That's because of the wavelength limit of the instrument. In addition, Hubble can only look back up to 500 million years after the Big Bang, while Webb can go back further to just 200 million years after the universe began. So, Webb has given us an unprecedented view of the Z greater than 13 era that has remained out of our reach so far. Galaxy discovery. Discovering galaxies between the redshifts of 13 and 14 is quite exciting for astronomers. In its first few weeks, astronomers have reported several candidates in that range, but a team of researchers took the game to another level by reporting a galaxy at a record redshift of 17. This galaxy has been officially named CS 1749, and it existed within the first 220 million years after the Big Bang. So, we are actually looking at the dawn of time. Stellar mass. The first thing that puzzled astronomers about this galaxy was its stellar mass. CS 1749 has a mass of 5 billion solar masses. That's a huge number, given the age of this galaxy. It's 5 times the stellar mass of GLZ 13, another galaxy candidate discovered by the James Webb Space Telescope at a redshift of 13.1, which we discussed in the 18th episode. The researchers noted in their paper that if CS 1749 is confirmed to lie at Z equals 17, it would force a major revision of early galaxy evolution models and potentially even our underlying cosmological framework. It is very challenging to produce such extraordinarily luminous and massive galaxies only about 200 million years after the Big Bang under standard assumptions in the framework of lambda CDM cosmology. This graph from the team's research paper plots the stellar mass threshold and the redshift of 4 remote galaxies, GN Z11, discovered by Hubble, and GLZ1 and GLZ13, which are Webb candidates. It can be clearly seen that CS 1749 lies in the region of the diagram that is in tension with the lambda CDM cosmology. If this galaxy is spectroscopically confirmed, and more of them are discovered in the tension region, it may provide a compelling constraint on cosmology. The researchers also computed this candidate's star formation rate, SFR, which came out to be 34 solar masses per year. That's almost 100 times that of the Milky Way, meaning the galaxy probably had an intense burst of star formation activity. UV brightness. Besides stellar mass, another strange parameter of CS 1749 is its UV brightness, or the absolute ultraviolet magnitude, MUV. In astronomy, the absolute magnitude of an object represents its brightness as placed 10 parsecs away. The lower this number, the brighter and more luminous the celestial object. CS 1749 has a MUV of -22, showing that the galaxy is exceptionally luminous. Such high UV luminosities are unexpected for a system lying a mere 220 million years from the Big Bang. This parameter indicates that something isn't right with our cosmology models. That's because CS 1749 is not the only one with such a high luminosity in the Z greater than 10 epoch. Even HD1, the most distant galaxy candidate discovered by ground-based telescopes, has a MUV of -23. So, if confirmed at Z equals 17, CS 1749 would be one of the most luminous galaxy candidates at Z greater than 10, second only to HD1 and comparable to the spectroscopically confirmed GN Z11. Schroeder's galaxy. Now comes the tricky part. Why is CS 1749 being called the Schroeder's galaxy? Although observations strongly support that the galaxy lies at a redshift of around 17, there's a non-zero probability of a Z equals 5 solution being true. The analysis of this galaxy strongly favors the Z equals 17 solution, but researchers chose not to rule out the accompanying possibility. And that's why they have nicknamed this candidate the Schroeder's galaxy, which seems to be at two places at once. It's analogous to the famous Schrödinger's cat, which is dead and alive both until you observe it. First clue. The first clue that this candidate lies at Z equals 5 comes from its local environment. The galaxy's 3 nearest neighbors all lie at a redshift close to 5. Next, the researchers determined the stellar mass of one of the neighbors, and it came out to be about 100 billion solar masses. So, if CS 1749 lies at the same redshift and therefore at a physical separation of less than 15 kiloparsecs, it may be an associated satellite galaxy of its massive neighbor. This is similar to the Magellanic Clouds and the present-day Milky Way. The Magellanic Clouds have a stellar mass of the order of 1 billion solar masses, and the Milky Way has 100 billion solar masses. Second clue. The second clue supporting the Z equals 5 solution came from the galaxy's morphology. Again, the results show that there's a possibility the galaxy is a clumpy disk or a merging pair. Given the hint that it lies in a dense protocluster environment, mergers are quite likely. CS 1749 may even be in the process of tidal disruption by its massive neighbors if they lie at the same redshift. Even if this galaxy is confirmed to lie at a redshift of 5, it challenges our cosmology models. That's because the Z equals 5 solution limits its star formation rate to just 0.1 solar masses per year. That's about 3% of that of the Milky Way. So, in that scenario, it would be the most distant quiescent galaxy found to date. Quiescent galaxies are systems characterized by their large stellar masses and sizes, several billion-year-old stellar populations, red colors, little to no active formation of new stars, and a very limited amount of cold gas and dust. Finding such quiescent galaxies at high redshifts of about 5 challenges our current understanding of galaxy evolution and the physics of feedback. Conclusion: there's more than a 90% chance that this galaxy lies at a redshift of about 17, and that we are looking at the dawn of time. Spectroscopic follow-up of this remarkable galaxy is critical to Webb's mission of expanding cosmic frontiers. The James Webb Space Telescope has finally opened the window into the last unknown epoch of our cosmic timeline, and we can't wait to find out what lies there. This marks the end of the 20th episode of the Sunday Discovery series. In the comments section, let us know what you liked most about this series and how we can improve it further. Lastly, if you enjoyed this video, make sure to like it, subscribe to our channel, and press the bell icon so that you don't miss any future episodes of this series.